Hello?
Hello.
Hello?
Hello. Good morning, Anand.
Good morning. Good morning. How are you?
Fine, thank you.
Thank you. Thank God.
We're glad to be here this morning.
Thank you. Thank you a lot. Glad for me. Started now.
Great.
Okay. Hi for everyone. My name is Hanan. I'm member of Olbgis, and all of you, you are welcome to our conference, which is about global warming and climate change. So today we are talking about how can spatial analysis decision making be effective to detect alternative places for climate affected areas using model builder. Now I'm sharing my screen. Okay. Okay. Seeing my screen? Hello? Hello?
Yes.
Are you seeing my screen?
Yeah, it's visible.
Okay.
Yes.
Okay. Now I'm speaking about how can spatial analysis decision making be effective to detect alternative places for climate affected areas using model filter. First of all, I want to speak about the people. People usually immigrated from their original places to other places or other countries due to harsh conditions they are going through, such as wars, floods, droughts, and economic conditions. This immigrate causes impact in climate by increasing in pollution, increasing in temperature, etc. For example, increasing in the or disappear for the water resources, okay, due to their activities and increasing in number of refugees. The highest rates of immigration move from African country to either African country or developed countries. One of these country, Sudan. Sudan has a long-standing tradition of hosting refugees. Refugees began arriving in Sudan in the mid of 1960. Immigration flows are mostly from neighboring countries, most the foreign in the Sudan. Around 6 million and 85 are recognized refugees coming mostly from Eritrea, Chad, and Ethiopia. For this fact, we have to make new camps to handle this increasing of refugees number. Okay, this fact, if you see this map, represent the facts of the refugees. There is a 75% of people from South Sudan and 51% of whom are women and 48% are under 18 years old. Here, I will speak about this map represent overlap in the land borders between Sudan and its neighbors. Okay, it's very easy and it's there is no difficult boundaries to detect our countries or the other countries, and there is the movement from Sudan to other country and from the other countries to Sudan. Okay. Because of the high rates of the refugees, come to Sudan each year. This causes high temperature between years that affect in climate. Okay, this map represents the impact of existing refugee in climate. Okay, this is rounded by black color. Okay, this point black, if you see here, this represents the refugees, existing refugees. And this is impact what happened in the years between 2014 and 2021. Okay, there is a high temperature during this area. For this reason, we need to find new location for the camps to handle the huge amount of refugees. Okay, we are going to GIS, what the rules of GIS and how can GIS help us by using many of available tools to solve the specific spatial problems. In our case study, we will use the GIS to find the optimum location for new refugees camps, depending on the several criteria using model. This is my study area. Sudan lies in the eastern part of Africa, and it has borders with Eritrea, Ethiopia, and many other countries. This represented the study area. If you see the oval, this red oval represents my study area in Sudan. Okay, White Nile from here. Okay, how can solve this problem? I used model builder. Okay, what is a model? Model is represented as representation of reality. It can help to understand and describe and predict how things work in the real world. Also can providing decision makers with dramatic visualization of alternative future. Okay, and we have two main types of models. There is representation models and process models. Representations models, that means represent the objects in the landscape. And the process model, that means interaction of the objects together and make relationships. Okay, to describe process, there is steps to do that. Okay, and before this, we need to know what is the suitability modeling. In the most common application for ArcGIS, its extension can solve a variety of problems. That means where to site a new housing development, where to locate a new sky area, where to deploy troops in a military operation, where to locate firefighting crew to fight fires in the dry season. For this case study, which is sites are best for pocket habits. Okay. Now we want to know understanding the suitability modeling workflow. The suitability modeling workflow to identify the best location to serve you. A suitability modeling is comprised of 6 steps. First of all, define the problem. We need to define the problem. Why to solve it? What's our problem? What is the type? What kind of our problem? That means identify and drive the criteria. I'm supposed to know what's my problem to choose my criteria or to my data, transform values to a common scale. Then weight the criteria relative to one another and combine. Locate the phenomenon. And the last, analyze and results. Overview of weight size selection and suitability analysis. Okay, this is just overview. What is the size selection or suitability analysis? Is a type of analysis used in GIS to determine the best place or site for something. Potential sites used in suitability analysis can include the location of a new hospital, store, or school, among many others. When performing site selection analysis, users must set various criteria from which the GIS software can rate the best or ideal sites. Site selection analysis can be performed with vector or raster data, but one of the most widely used type of site selection, weighted site selection, uses raster data. When to use weighted site selection in GIS? It's best to use which raster data. We need to find a site based on number of criteria, such as following problem explained by the ISRI, okay, using raster data for site selection. For what to find the ranking of suitability for cells in raster dataset, to find next best site options, in addition to finding an ideal site that has distinct boundaries and other levels of certainty. The user determines where something will go based on specified criteria. The user wants to rank different criteria as more or less important in finding an ideal site. Okay. We need to, for this, explain for the last slides, need to choosing the potential site in the study area. Okay, to start this, I used to start it. This study area have criteria. This criteria, it may be 23, 25, 30, depending on the case study. Criteria, it will be depending on our study. Okay, in this study, I choose criteria elevation, that's sourced from USGS, United States Geological Survey, that source them, or I need road from Google Earth or digitizing routes, and existing refugees camp. This come from GPS, Global Position System. That means go to the field and take some points from the existing refugees, and land use, land cover. Okay. For start this, I used Model Builder. I put all these criteria in Model Builder, which can be defined as an application used to create and edit and manage models. Models and define our workflow that string together sequences of geoprocessing tools, feeding the output of one tools into another tools as input. Model Builder can also be together of as a visual programming language for building workflows. The benefit of Model Builder, what I want from the Model Builder, how can help me. Okay, is easy to use, very easy and save our time. And you can create your own tools with Model Builder. You can use the Python scripting and other models to create Model Builder. And you can integrate the Model Builder with ArcGIS, with another applications. Okay, these figures show, sorry, This figure show the model, how can model present it. Okay, I started with input data. This is the input data. This is the criteria, input data, and that is the yellow color is the tools. I use it from software ArcGIS, and this green color, that is the output. Then the output will be input and make a processing, another processing to give me another output. That means of sequences of processing. Okay. In our case, I used road and I used elevation and I used existing refugees. What I want from the roads and refugees and elevation, I want the buffering or the spaces or distance between points and points. For this, I used Euclidean distance. Okay, Euclidean distance, and give me the results. The results, it will be like this. Euclidean distance tools, what is doing, calculate each cell, okay, and convert each vector data to raster data to calculate cells value. I have road vector data and I have refugees vector data, okay, and I have a slope. This is the raster data. It will do in the raster data, calculate the cells. In the vector data, convert each vector to raster data and calculate cell value to give this result. Results, that means this color is, that means is closest from the refugees, existing refugees, and they're from the road, okay, existed. Here the slope. Why I use the slope? Slope tell me the steep of the terrain, okay, and it can calculating the maximum rate of changing between each raster cells and its neighbors, okay, and give me output of maybe percent of slope or degree of slope, okay. Then the next step is reclassify in ArcMap. Why I used reclassify? Reclassify used for changing values in raster, okay. For what? To give me a chance to rank the old values to new values from 1 to 10. Like this. This is the old value, okay. That is came from the this is the output from the Euclidean distance. This is a distance, okay. This is the old value. Now I want new values depending on this distance, okay. I want that is I need for me I choose the best values. This is a 10, okay, and I want, for example, refugees to be far away from the new refugees, far away from the existing refugees, okay, to avoid it climate changing, okay. These tools, when I click in ArcMap and open this or pop this windows, choose classify, and I found classification methods. This is a classification method, standard deviations, manual, equal interval, defined interval, quantile, natural breaks. I used natural breaks in these cases, okay, to be natural without any manual, okay. This is the result. It came like this. This is reclassify for my criteria. Then all this, I will put it in weighted. Why I do weighted? Weighted for each criteria, it's supposed to be has weighted individually. And so total sum weight is 100%. Okay, depending on what is important or the priority of which criteria is important, or it's very, very priority. I choose slope 13%, reclass for refugee 25, and for roads 12, and land cover, land use 50. And ranking in this field, okay, I put it the last land use and land cover in weighted in the last, because I want to this values, this field, I don't want it in the numbers. I want it like this as land use and cover, because I want to know what this number means. 5 equal 3 cover, or 13, that means per land, what I want. Okay, and I have to know what I want from these values. For example, I don't want water bodies and pay, and I want I don't want per land, and don't want three covers, and give score for this. Okay, to give us the results, the final results, suitability analysis. This is the final results. After calculate, I got these places is the optimum places that have green color. Okay. After that, I have to calculate the these areas. To calculate it, I have to convergent the raster to polygon to calculate it from the attribute table, calculate geometry, and give me the areas. These areas, and give us the optimum places. And for keep our global safety from danger and destroyed, I recommended good behavior in sustainable development, preserving the environment, and replacing polluting industries with alternative industries. And thank you. Any questions? Hello? Hello?
Hello?
Yes?
Hello, Ms. Hanan.
Hello? Hello?
I'm Mr. Bacon, and I think you are hearing my voice.
Yes, I'm hearing your voice, okay?
Okay, thank you. And I have seen your presentation. That's very impressive and good presentation. And since we are just instructors, and since we have some experiences on these tools and maybe the ArcGIS, and you did very good, and it's great. Thank you for this presentation. And I do have maybe one question for you.
Okay.
My question is that on the tool that's for the weighted overlay tool.
Okay.
We couldn't give the value or the percentage of influence for the parameters just randomly.
Okay.
And there must be maybe universally accepted values, or maybe there must be the literatures that uses this parameter and the influence or percentage influence for different parameters. So how could you take or how do you decide the influence or the percentage of influence for those parameters like the land cover and another
Okay. Okay. This is a good question. It's a good question. I will answer to it. I choose this percentage from the standard from UNHCR. Okay, this is a standard from our countries. I use it and put it in my project. That's all. I research, yes, I research on it.
Okay.
This is a standard values, or yes.
Okay, that's great. Great.
Thank you. Okay, thank you. There's another question. Hello?
Hello, Mr. Sebastian. I think they're going offline.
Sorry?
Hello?
Yes, I'm here.
Are they going offline or what? We are not hearing their voice.
Really? I don't know. Now, can you hear me?
Yeah, I can hear you now.
Okay, okay. Welcome.
Okay, Hanan.
Yes, yes.
I must first of all congratulate you for a great presentation.
Thank you.
And you're actually able to bring to life the GIS implication on how migration could be reconciled across not just North Africa, but also across Africa. And I must say, this is a great learn for today. And I wish I had a couple of other professionals on this presentation here. Now, I want to ask, now I know the scenario you painted was typically around migration. Now, could this be implemented on urbanization?
Sorry, I can't understand your question.
Okay, what I mean, I know the case study you cited was centered around migration and how it could how GIS could be used to plan settlements.
Okay.
Now I'm saying the modular builder that you mentioned, can this still work out in the case of urbanization, that is migration from cities to cities within a local area, not just across border?
Yes. That you means how can detect all this, or if I understand your question?
Okay. Like what I'm saying is, let's take Nigeria for instance. Yes, then we have a couple of cities in Nigeria, say Lagos, Ibadan. Now, which is likely a different scenario from comparing a transnational movement from one country to another. Can this technique also be used to measure how these demographics can be set in these various cities?
Yes, it can. It can help these techniques. It can help.
Okay. Thank you very much.
Okay, thank you.
Yeah. Any other questions?
Any questions?
I don't think there is another question. So
there is another question.
I think they are just make their speaker muted, so it's better to just give the conclusion and
Mute my.
Okay. Let's allow Mr. Olivia Besam to quickly give a word of notes as we kick off this conference. Thank you. Mr. Olivia, are you available for your speech?
Hello, Sebastian. Do you hear me?
Yes, yes, clearly. Hello? Hello?
Hello, do you hear me?
Yes, you're clear. You're clear enough.
Okay, sorry, with the background noise, it's a pleasure to have all the attendees for this event. Today, we have opportunity to share the knowledge with Hanan. I hope that this event was very helpful and grateful for everyone. So just keep in touch for the next day with some experts in the GIS field. We have opportunity to discuss with Dr. Mwashi and Mr. Bekan. Also, Mr. Fatma. Okay, Mrs. Fatma. So have a good enjoy and see us tomorrow. Sorry.
Okay.
Hello. Hanan?
Yes.
Hello.
Yes,
Yes,
I'm here.
there's a question from Trevor.
Okay.
Trevor is asking, hi, can the speaker expand a little about the modeling if the output comes out automatically?
Yes. You mean the model, it's running automatically in ArcMap?
Yes, I believe that's what Mr.
Yes.
Trevor was trying to ask.
Okay. Yes, it's using very easy. Just building your model and click on the run, and it will be automatically give you the results. If this is your answer to your question, that is, or
hello,
yes.
Mr. Trevor Musa. Does this meet your response? Or does this meet your question? Sorry. You can unmute and respond.
Okay.
Hello, Mr. Trevor. Okay. Question answered. Thank you, Hanan.
Thank you a lot for you. Okay.
So at this point, okay, Mr. Trevor is saying he has audio challenges. He's saying he has audio challenges, so he might not be able to respond at this moment.
Okay.
But he just sent thank you, meaning he has actually understood what you have shared. Okay. Thank you, everybody. So thank you. Thank you, Hanan. Thank you, Mr. Bekan. Thank